Discover yourself, who you are, what you can do in your life. Let's ask from brain to think and talk to act accordingly.
Hello. Welcome to the Numpy tutorial. In this tutorial, we are going to learn about Numpy and its uses, how to install Numpy, how we create arrays in Numpy, and in the end we will do some operation with Numpy arrays, so stay connected with us. Well, Numpy stands for Numerical Python. It is an open-source Python library that used in almost every field of science and engineering. It's the universal standard for working with numerical data in Python, and it's at the core of the scientific Python. Basically, in Python Numpy is used to working with arrays. Wait. Now you might think, if we have a concept of list in Python, then why we use Numpy arrays? The answer is, Numpy arrays are much faster because an array is a collection of homogeneous data types that are stored in contiguous memory locations. On the other hand, a list in Python is a collection of heterogeneous data types stored in non-contiguous memory locations. Numpy used in the variety of fields like data science, big data analysis, artificial intelligence, machine learning and deep learning, and so on. For Numpy, your PC must have a Python installed. I suppose you have Python installed already. For installing Numpy module, open your command prompt or terminal and write the command pip install Numpy. Hooray! We have successfully installed Numpy. At first, open your favorite IDE. In my case I am using the Google Colab IDE, which is provided by Google. You can use it online for Python programming. From here you can change the name of project. For using Numpy you first have to import it. For that, write import Numpy as np and hit Ctrl+Enter key to execute the current cell. After importing Numpy, we will have to create an array using np. Firstly we define a variable r, where we can store values. Like, here the numbers from 1 to 5 is stored in array. In the parameter of np.array, we pass the list, which contains homogeneous data. However, we can create arrays by passing the tuples as parameter. For output, we will use print function, and pass the variable name as parameter, where we store the array values. Previously we created 1D array. Now let's create arrays with different dimensions such as 2D and 3D. Well, a dimension represents a direction in which you can vary the specification of an array's elements. Such as, a two-dimensional array is a tabular representation of data, in which the elements are kept in rows and columns. And three-dimensional. The first square bracket represents the level of the array. Second would be the number of rows. And the third one is for the number of columns. Note the changes in the 1D and 2D array. In 1D array we simply provide a single argument. However, here we are providing two lists. In single one by separating with comma. In 2D array we simply provide two lists in single one by separating with comma. And in 3D array we are making nestation of two lists. Hence the process will go on until n dimension. The first operation we are going to perform is array indexing. Basically, indexing helps us to access or search particular element in array. The first element of array always have index 0. Second element has 1. And it goes until the length -1. Like this array is created from values 1 to 10. Now we want to access first element. we have to pass the 0 index in the brackets of array. And if we want to access element with value 7, we pass 6 in brackets. Similarly, in two-dimensional arrays, we access the element by passing row number and column number, and we get the element 2. Second operation we are going to perform is array slicing. Wait. This slicing is not like slicing bread or pizza. Array slicing in Python means taking elements from one given index to another given index. Like, here we have created an array which contain values from 1 to 7. Whenever we do slicing we pass start index and end index in the brackets. Here we have passed start index 1 and ending index as 5. In result we should have 2, 3, 4, 5, 6. But wait. Did you notice? 6 is not visible in output. The reason is simple. The last index we pass to slicing is considered excluded. There is another parameter we use while array slicing. This is used to define the step. If we don't define step it is considered 1. Like here. Step is defined 2 with starting index 1 and ending index 5. Now list will be sliced as 2 and 4. There are a few more things. While slicing array, if we don't define start indexing it considered 0 index. If we don't pass end index, it's considered length of array. And if we don't define both then it start from index 0 to length of array. Now we are going to learn about shape attribute of array. Shape attribute is used to check array shape. It returns a tuple with each index having the number of corresponding elements. Like this array is two-dimensional with 2 rows and 4 columns. Hence, it return a tuple with value 2 and 4. For getting this just right, array.shape in print function. We have another amazing property called array reshape. Array reshape property helps us to change the dimensions of the array. By reshaping, we can add or remove dimensions, or change number of elements in each dimension. Like, here the array created from 1 to 12 in one dimension. For converting it into two dimension, we can simply go with 4 rows and 3 columns, or 3 rows and 4 columns, or take any possible combination that fits with all elements. For converting it into two dimension, pass that combination to reshape property. Like, here we pass 4 rows, 3 columns, and we got the output in 2 dimension. Till now, we have covered the basics of Numpy. However, Numpy also have properties like array join, array split, array sort, array filter, and there are advanced sub-packages like Numpy random and random data distribution. These packages are used to work with statistics and data science. With Numpy we can also perform universal functions like arithmetic, logs, LCM, GCD, trigonometric, and so on. For exploring the more topics on Numpy, you may visit Python tutorial on W3 Schools. Thank you for watching this video. Follow Brain Talks to learn more.